Welcome back to Artcraft Electronics videos. This is Chapter 3 in our simple solar-powered battery charger system. In Part 2, we defined the battery and solar panel requirements for our system. Before moving on, I'd like to revisit the solar panel calculations with a simpler approach. Some viewers may have thought the calculations in Part 2 were a little complicated, so let's reduce it down to the basics. We know the charging current is 20 amps, since that is the maximum charge current available from the Victron solar controller. A solar panel behaves a lot like an unregulated power supply. As the current increases, the voltage decreases in accord with various components in the power supply. The panel we selected has an open circuit voltage of 27 volts and working voltage around 24 volts. To keep the math simple, let's assume that under a 20 amp load, the panel voltage drops to 20 volts. P equals IE. 20 amps times 20 volts equals 400 watts. So that gives us about 400 watts of solar panel power required. This lines up very well with the design conclusions from Part 2. Now, depending upon your location and weather conditions, your needs may vary. If you're only topping off the battery, a single 200-watt panel might be enough. If you live in an area with frequent cloud cover, you may need 3 panels. But for many people, 2 200-watt panels should work very well. Oh, by the way, I saved the solar panel shipping box. It's really useful during installation, when we might not want to be generating voltage. Okay, now let's go to the photovoltaic circuit breakers and disconnect wiring. I decided to use a combined breaker and disconnect assembly rated for DC solar service. The model I selected includes a 30 amp DC breaker, a disconnect switch, MC4 connectors, and a weather-resistant enclosure. At the time I purchased them, they were about $28 each. This assembly provides both the DC-rated 30 amp breaker disconnect and, at the time I purchased them, cost $27.88 each from Amazon. They came with an MC4 disconnect tool, 2 sets of MC4 connectors, and installation hardware. That's a good deal, and it's exactly what I wanted. The charger to battery disconnect would also be a good choice for this assembly, with some modification. So another one would work for protecting and switching that circuit. Here's why I liked these assemblies for the project. The breaker rating is sufficient to provide safe operation without nuisance interruptions. The reset switch works well as a disconnect. The assembly comes in a water-resistant enclosure. It's terminated with MC4 photovoltaic connectors. The wiring is 10 gauge, which will handle 30 amps, and the package comes with additional MC4 connectors and a neat little MC4 tool for disconnecting the MC4 connectors. This fulfills all the requirements for both the photovoltaic circuit and the battery charging circuit for the breakers and disconnects. That was an easy choice. Now, you could be making this a lot more simple by using automotive fuses, which work well at DC. Automobiles use a lot of DC, 12.8 volts or so. So that would work as well. It depends on what you would choose. I want to give you some good choices here, from one extreme to the other. The breaker and switch is really kind of fancy for this circuit, but I like having that kind of utility in one box. Okay, where are we? We've got the PV and battery charging breakers and disconnects. Okay, going back to the simplified block diagram, we have the solar panels to the charge controller to define, and also the charge controller to the battery cables that are going to need to be specified. So let's get to that part of it. Since the system is intended to be semi-portable, 10 feet of panel to charge controller extension cables should be sufficient. And about 3 feet of number 8 AWG should work well for connecting the charge controller to the battery. If you want more distance from this assembly to the battery, get longer number 8 cable, because it'll handle 20 amps continuously for just about as long as you want it to. I mean, don't go 50 feet or so. You'd probably be best to keep it to around 15, 20 feet, just to manage the cables in a portable application. Let's start with the solar panel extension. Temco makes excellent extension cables that are plug and play in this assembly. And I chose a Temco solar panel extension cable number 10 AWG, 10 feet of red, 10 feet of black. And the Temco extension cables come with Stobly MC4 connectors. I like those. So they're pre-installed, and that saves a step. If you think you will need more or less than 10 feet, Temco will work with you. Next, we will describe the Victron charge controller to PV disconnect breaker circuit. The disconnect switch circuit breaker comes from number 10 wire for red, number 10 red and number 10 black wires with the Stobly connectors, as I mentioned. Don't know why I put that down twice. But that's going to be our PV input connection. For the output side of the PV disconnect breaker, we will cut off the MC4 connectors as closely to the connector as possible and strip the ends for insertion into the charge controller PV input connection points. Oh, here's an important detail when working with stranded wire. Many technicians twist stranded wire after stripping the insulation. For this connection, don't do that. The Victron terminals are extremely tight with 10 gauge wire. Twisting the strands actually increases the effective diameter of the wire slightly and makes insertion into the connection point of the charge controller more difficult. Instead, keep the strands straight, keep them tightly aligned, and insert the wire carefully. If a strand hangs up, stop and correct it before tightening the terminal or even continuing putting it into the terminal. When you have inserted the wire into the connection point, hold it there. You worked hard to get it there. And continue to hold it while you are tightening the charge controller connection screw snug and secure. Don't over tighten it, but snug and secure. After doing so, give the wire a tug to check tightness. Now let's look at the battery charging circuit. Number 10 wire can carry 20 amps for a few feet safely. So that's what we will choose to connect from the charge controller output to the battery breaker disconnect. I chose to cut off the MC4 and use the wires that came with the breaker, and after stripping 3/8 inch of insulation, connected the breaker to the charge controller. You will need to observe the same method described earlier to connect the stranded wire to the charge controller output. Red to positive and black to negative. Keep those strands straight. Be careful while you're connecting to the charge controller. For the output of the breaker, I wanted a pure copper heavy-duty wire and connector between the disconnect and the battery. The disconnect comes with a number 10 AWG wire, and it's terminated in an MC4 connector. It's a short interface cable on both the input and output. Well, on the output, number 10 is okay for 20 amp service, but the included connection terminated in the MC4 connection was too short to make it to the battery. So I decided to use number 8 AWG stranded wire for this connection. I purchased 3 feet of number 8 in black and another 3 feet in red at Lowe's. Part of my decision to use number 8 was the availability of heavy-duty battery connectors that would accommodate number 8. I had Eric heavy-duty copper cable lugs in AWG 8 with 3/8 inch rings in bench stock. These cable lugs are available on Amazon. I'll add the wire, cable lugs, ferrules, etc. to the parts list. The heavy-duty cable lugs are crimped with an AMZ. I better spell that. AMZ-CNC. If you can pronounce it, go ahead. Anyway, that hammer lug crimper tool, model number NY0001, also available on Amazon. The other end of the battery cable connects to the disconnect output. I had previously disassembled the disconnect to remove the number 10 wire on the output. The number 8 wire is attached to the connection points vacated by the number 10 wire that I removed. Oh, on that particular one, I was able to use Aric, AIRIC, nylon wire ferrule terminals in AWG 8, and I had those in bench stock, but they are available from Amazon. At this point, it makes sense to update the parts list, because next we will go into the assembly section of the project. Okay, this project is as I built it. It is not a how-to-do-it DIY project intended to be constructed by the viewer. I don't claim to be an expert or a trainer. Rather, it is a description of how I intend to build my project. It's not the only way to build this project. For instance, some might use the automotive fuse assemblies I mentioned earlier. Maybe you want to use a Renogy or a different solar charge controller manufacturer. Considering experience with this project design, I see things that I could do differently. Well, I think this will be a terrific introduction for me, and I hope for you as well, to solar system construction. This episode focused on the electrical design, wiring choices, component selection, and the bits and pieces necessary to build the system. Part 4 is going to be very much more hands-on. We'll assemble a system, wire everything together, power it up, and perform initial testing. This is what I have been waiting for. It should be a lot more fun. Thanks to all who have subscribed and selected notifications. If you haven't, now would be the perfect time to do so.